Hello, let's continue our Sudoku Adventure with Four Corners by rockratzero. So we have a 5x5 Sudoku today, and in 5x5 there are no regions, at least not in this one. So in every row and every column we are placing the digits 1 to 5 exactly once each. We also have killer cages in the grid. These work as you might expect if you've done killer cages. Digits can't repeat in a cage, so normally I could put a 5 here and a 5 here and a 1 here to add to 11, but that repeats a 5 in the cage. So that's very much not allowed. But what we do is we take the digits that go in the cage and we sum them, and they sum to the top left value. We also have two crop key dots in the grid. One's black, one's white. The white crop key dot separates consecutive digits. So if this is a 2, this must be a 1 or a 3 in order for these to be consecutive. And the black crop key dot separate digits in a 1 to 2 ratio. A good way to put that is 1 is exactly double the other. So if this is 2, this could be 1 because 2 is exactly double 1. Or this could be 4 because 4 is exactly double 2. So the order doesn't matter. What matters is that 1 is exactly double the other. All right, so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So how do we want to get started? 12 feels really big for a 5x5. So what's the biggest we could add to? 5, 4, 3 is 12. So this has to be 3, 4, 5. We need to subtract 1 from that in order to get to 11. But the only digit we can subtract 1 from without repeating anything is the 3. So we end up with 2, 4, 5 in these. Okay, so let's see here. This 8 definitely has a 1 in it. So it's either going to be, I was going to say it could be, yeah, it could be 1, 2, 5 or 1, 3, 4. That's literally any of the digits, but it has a 1 in it. Okay, well 5 can't go on a black dot because we can't divide it by 2 and we certainly can't multiply it by 2. So there's a 5 in one of these two. So I'm wondering where 5 goes in this column in this row. So let's talk about this column first. So we know that this 12 cage has a 5 in it, and we know that this 11 cage has a 5 in it. In fact, we know it's here. So that's all the 5s we get for these two rows. These two rows only have two 5s. One of them's here, one of them's here, which means there is no 5 here or here. So these are non-5 values, I suppose you could say. So let's just actually fill 1, 2, 3, 4, and then these can't be 4. Maybe the corners are the important bit. That's why it's called 4 corners. It does put a 5 down here. Okay, so with the 5 down here, let's just focus on 5s for a little bit. That means there's no 5 in this cage because there's a 1 5 here and there's 1 5 here. That's all the 5s we get for these rows. So again, this can't be a 5, but if there's no 5 in this cage, then this cage is a 1 3 4 cage. Okay, so now I'm going to focus on these corners. Let's actually seed each of these corners with 1 through 5, and let's do some obvious deductions first. So this can't be a 5. In fact, with 2, 4, the 2 can go with, yeah, it can't be a 5 or a 3, right? So I guess in a 5x5, you can't put a 3 on black dots either. I didn't actually immediately realize that. So black dots always have a 2 on them. Good to know. But that's not really what I want to do. Now down here, we can't put a 2 because there's no 1 or 3 here. But what I was going to do is I'm going to say, okay, what's the common digits between these two? 4 and 5 are common. So that means none of these can be 4 or 5. So specifically, this can't be 4 or 5, and this can't be 4. So this can't be a 5. Now the common digits between these are 4. So this can't be a 4. And that's it. The common digits between these is 4, so this can't be a 4. And then the common digits between these are the 4 and 5. Okay. This not help as much as I assumed it would? Okay, well let's think about 5 in this row then. It's going to go over here because these 5s line up. So these can't be 5. So the 5's over here. And that does mean this can't be a 5 because we have a 5 here. Actually, these 5s point down. That places this 5. That makes it much more obvious that this can't be a 5. So this is a 5 for the row. It's the only place 5 goes. All right, now I think we're making good progress here. I think I've got the point to the puzzle, but we have to finish it off. What's going on here? 1, 2, 3, 4, 5 are all represented. This is just from 1, 2, 3 though for the column. These are from 1, 2, 3 for the row. Okay, so in this column, the 2, oh no, the 2, sorry, I thought I saw something that was limited to one of these cages, but I don't think so. All right, there's something else going on here. You know, for a puzzle called Four Corners, there isn't a single 4 in a corner. All right, what are we doing here? We know there's a 5 here. I suppose I could mark that. We said there's always a 2 on this black dot because it's either 1, 2 or 2, 4. So this can't be a 2. That leaves a 1, 3 pair here. So that's not a 3. That puts a 3 up here. What's that do? That means that's not a 3. That puts a 3 up here. Okay, so there's a 3 in this cage and there's a 3 over here. So this can't be a 3. Using this trick a lot. This is a 1, 2 pair now, so that's really helpful. That places this 3. So first of all, these can't be 3s. But it also means this can't be a 2. So there's a 2 over here, which means this can't be a 2. Because the 2 in this cage is in one of these two. Interesting, yeah. So this is a 1. That's a 2. That places the 2 in this cage, which could go with 1 or 3. That leaves a 1, 3 pair here. This is a 4. This is a 5, 2 and 4. These are not 4s. This is not a 2. All right, that gives us this 4 and this 5 and 4, 3 and 5. This is finishing now. Very nice. Well, this was a neat puzzle. I liked the use of just the same thing over and over again, basically of limiting, like, okay, the digits have to be in this cage or in this column or in this row or something, and so then they can't be specifically in the other cells in those 2 rows or 2 columns. I do wonder if there's kind of a more global argument that could have been made, but I think the way I solved it is perfectly fine. Actually, I'm back for some post-game analysis, maybe? I don't know how you want to put that. But yeah, I actually have a calculator here, which we'll be using. But I wanted to show, I tinkered around with this a bit, and I wanted to show a cool kind of global deduction you can make, which does speed up kind of the intro to this puzzle. It doesn't solve the whole thing, but I think it's really neat. And this is the kind of thing you would do in kind of more difficult, more advanced variant Sudokus. Shows up a decent amount, obviously not every puzzle. I'd say maybe 10% of puzzles, maybe even less, but it's still a really good trick to know. And I think it's really interesting. So hopefully you find this interesting as well. But what I'm going to do is I'm going to start by highlighting these 5 columns. I'm going to make those green. So what can we tell? What can you tell me about the sum of the green cells? Well, we know that a single column sums to 15 because 1 through 5 sums to 15. So if a single column sums to 15, we can do 15 times 4, and the green cells add to 60. No matter how the digits are arranged in this 5 by 5, these green cells will add to 60. We could have also just done that the entire puzzle is 5 times 15 and we subtract a column, but I don't see why we'd need to do that. So now what I'm going to do is I'm going to remove these killer cages because we actually know the sum of the killer cages. So if I take these out of green, then the sum of these killer cages, we can subtract 12, we can subtract 11 again, and then we can subtract this 8 down here. And so the remaining green cells we know sum to 18. Now what can I tell you about this? Well, we know the sum of these because this given 4 is here. And so the entire row is 15, but they're missing the 4. So the entire row, if I remove these greens, will sum to 15 minus 4, which is 11. So we can subtract 11 from this. And that leaves 7. That means that these 4 green cells here that are remaining have to sum to 7, exactly 7. Now, if you think about it, if they were all 1, 2 pairs, which is the minimum they could be, then that would sum to 6. And so with these 1, 2 pairs, one of these that would have been a 2 is going to end up a 3. So we're going to have 2 1s in these green cells, either here and here or here and here. And then we're going to have a 2-3 pair. So if you think about that for the whole puzzle, you can actually get quite a bit done, because we can actually just from the start, we can say, well, 3 doesn't go on black dots. This black dot always has a 2 on it. So this is not a 2. From 1, 2, 3, we can only put, well, actually, we might as well just fill these as well. So this would be 3, 4, 5, and these would be 2, 4, 5. And then this, because of the thing with 5s we did earlier, basically 5s are here. This is 1, 3, 4. So, but one thing we can do is we can say, well, because we know there's 1s here or there's 1s here, none of these can be 1s. The 1s are used up. And so this 8 cage needs a 1, so we're going to put its 1 there. And then, let's see. This can't be a 5 because of the... In fact, this is even, so this can't be a 2. And that makes our 1, 3 pair here that we got earlier. So that's a 3 and 5, 4, and 3. This is a 2. This is 1 and 3. And now that we know where the 3 went, actually, as soon as we got the 1, 3 pair, we knew that this would be a 1, 2 pair, but that actually does just finish. And you can see that we're basically getting the puzzle done very quickly at this point. Now, I did already know the other deductions in this puzzle, so it's not great to judge it this way, but I mean, the rest of this is just fillable. Should I do it? I guess I might as well do it. You literally just fill the rows and columns. This is a 3. This is, oops, there's no 6 in this puzzle. This is a 1. This is a 2. This is a 1. This is a 2, and this is a 5, and there we go. So I don't think I restarted the counter, I'm not sure. But either way, I think that's really neat that you can sort of make that deduction about the corners, and the rest of the puzzle just kind of fills in from there. I think the only thing we had to do is exclude 5 from this 8 cage by knowing that 5s were here. Or we could know that 5s were here with this 5. But other than that, I mean, maybe just knowing that this was a 1, because we had 1s here and we had 1s here, just knowing that this is a 1 might have been enough to kind of finish off the puzzle. But yeah, very, very interesting. So that could have been a way that you solved this. Who knows? Let me know if this is how you ended up approaching it. But yeah, often thinking about global deductions like that, combining a bunch of clues together in a way that is intuitive to us, and then remembering that through the solve, can really streamline solving puzzles like this. You're not like case checking or doing a bunch of markings and doing them one at a time. You're sort of getting this global deduction. So I really enjoyed that. So thanks, Rockrat. I'm not sure if you intended that, but it is in the puzzle and I quite enjoyed it. And yeah, so I'll do my sign off again. If you enjoyed this content, why not leave a like, subscribe, and a kind comment below.